Hi students, in this video we are going to describe about speed, velocity and position time graph or velocity, and how to calculate the velocity of a body moving with uniform velocity and non-uniform velocity. First, let us see what we mean by speed. The speed of an object is defined as the total distance travelled or the total path length divided by the time taken. So it is a scalar quantity because it has only magnitude, it has no specific direction. The SI unit of speed is meter per second, but the higher units, kilometer per hour, also is used. Speed is always positive. Uniform speed. Uniform speed of an object. When an object covers equal distances with equal time, then the speed of that object is known as uniform speed. And when an object covers equal distances with unequal times of interval or unequal distances with equal time interval, then it is called non-uniform speed. Then the average speed is also generally termed as the total path length or the total distance covered by the object by the time interval or the time taken. Velocity of a moving object can be defined as the displacement of an object or within a given time interval is called as the velocity. Displacement we have discussed in the previous session that the shortest distance between the initial point and the final point is called as displacement. The position of an object at time t1 is x1 and the position of an object at time t2 is x2. Then the distance between them or the displacement between them will be x2 minus x1, and the time difference that gives the time interval, that is t2 minus t1 gives the time interval. And if it is so, then the velocity can be written as delta x divided by delta t, that is change in position divided by change in time, and that gives the velocity of that object. It is a vector quantity. It has both the direction and units and dimensions of this velocity is same as that of the speed. Velocity is said to be uniform if an object covers equal displacement at equal intervals of time, however small the interval may be. And it is important to note that an object is moving with uniform speed may not have the uniform velocity, but an object is moving with uniform velocity always will have the uniform speed. The next is average velocity or instantaneous velocity. The instantaneous velocity of an object is defined as the limiting value of the average speed velocity of the average velocity as the time interval delta t infinitesimally small. V instantaneous is equal to limit delta t tends to 0 delta x divided by delta t, that is equal to dx divided by d. In terms of differential calculus, dx divided by dt is termed as differential coefficient. So we may say the instantaneous velocity is equal to the rate of change of displacement of the body at that very instant. Position, time graph and velocity. By using a position time graph, we can easily calculate the velocity of a moving object, either with the uniform velocity or non-uniform velocity. Let us see how does the calculation with the help of a position time graph. So the average velocity, we have already seen that it is displacement divided by time. So that is equal to the change in velocity change in position divided by change in time, that is delta x divided by delta t. If graph position time graph extend an angle theta, so we know that if an object is moving with a uniform velocity, the shape of the graph will be a slope. That means here we can see the position of the object x1 and x2, that is the change in position, and the change in time is t1 t2, that is a change in time, and the shape of the graph is a slope. And if we calculate the particular instant, the change in the position at this particular time intervals t1 and t2, and this will be the difference in the time and the change. And if we connect this to these points, and we see that a slope we can see there, and this slope subtend an angle theta here, and theta is measured in anti-clockwise direction. So, and this slope gives tan theta. Tan theta is equal to BC. BC is what? BC is the change in position divided by AC. AC is the change in time. Then BC is change in position is the displacement, and AC is the change in time, that is the time interval. So we will get tan theta is equal to BC divided by AC. That is equal to delta x. BC is equal to delta x and AC is equal to delta t. Delta x divided by delta t, that is equal to what? Velocity. So that will be the velocity of that moving object. Clearly noted that the angle theta is measured in anti-clockwise direction. If the angle theta is an acute angle, then the value of velocity will be positive. And if the angle theta is an obtuse angle, then the value of the velocity will be negative. Then non-uniform motion along a straight line. So we have seen that how we calculated the velocity of an object moving with uniform velocity. The same way we can calculate the velocity of an object moving with non-uniform velocity. From the shape itself we can understand that, and the graph is not straight. When that means the object covers unequal displacement at equal intervals of time. So, if we consider 2 points, for example, if we consider the positions of the object x1 and x2, and the time interval is t1 and t2. So, when we take the change in position and the interval of time, so we will get the change in position and the change in time. So we will get the value of delta x and delta t. Here we will have a corresponding value for the corresponding time t1 and the corresponding time x1. So make a point here, and for the corresponding time t2 we will have the position of the object, and we will get another point here. And now join these 2 points with a straight line. That will be the slope, and that slope will be the value for the average velocity of the object moving with non-uniform